13.6, solving quadratic equations by factoring. Okay, let's jump right in here. And notice we're going to solve a quadratic equation by factoring and then write equations given the roots. Okay, quadratic equations are equations that can be written in the form of ax squared plus bx plus c equals 0. Notice it's not an expression anymore. Okay, now our definition is specifically stating right here, okay, equal to 0. Okay, that's going to be very important. Where a, b, and c are real numbers and a cannot equal 0. Notice if a does equal 0, you no longer have a quadratic equation, you now have a linear equation, okay? Which sometimes is going to happen, you'll see that later on. Okay, so let's kind of continue on. If the product of two or more factors is 0, then at least one of the factors must be 0. That is, for real numbers a and b. If a times b equals 0, then either a can equal 0 and or b can equal 0. Okay, that's the zero factor property. Makes sense if you really think about it. If I just tell you a and b are 0, one of them has to be 0. We don't know which one, and it could be both, but one of them has to be. So let's come in here. Okay, notice solve x minus 5. This is going to be something in factored form. Okay, this was a quadratic at some point in time, but notice now they've made it equal to 0. Okay, so you can imagine some sort of quadratic over here. It's going to be in the form of 2x squared. Okay, I can guarantee that. And then of course the very end, and then the very last number is going to be a positive 35. So since the quadratic is already factored and the other side of the operation equals 0, we use the zero factor property and set each factor equal to 0. This process yields two linear equations which can then be solved. Okay, what they're saying is this. Okay, I have x minus 5, 2x minus 7, all equal to 0. Well, what it's saying is the zero factor property says I'm going to set both of these equal to 0. So I have x minus 5 is equal to 0. And then I have 2x minus 7. That is equal to 0. Okay, when I come in here, I'm going to solve for x. So I'm going to add 5 to both sides. And here I get x equals 5. Here, 2x minus 7, notice I'll subtract 7 from both sides. I get 2x is equal to negative 7. Divide off the 2, and then I get x is equal to negative 7 over 2. So here, my answers are x equals negative 7 over 2 and 5. This is saying if I plug a 5 back into here, notice it's going to make this guy 0. Okay? But then this guy's okay. Okay, or if I plug in the negative 7 over 2, if I plug it into this guy turns to 0. But that's what the zero factor theorem tells us. That's okay. Okay, and so that's how we solve. Once you see these graphically, it's going to make a lot more sense. Okay, because you see what these do. Quadratic equations create on a graph, if I graph this for you, a graph that looks like this. Okay. And these answers to this equation, not this specific one, will be places, okay, where zeros happen on the x-axis. So here's your x and here's your y. Okay, so sometimes you'll see it like, you'll hear people say, what are the zeros? Well, those are the zeros. Okay, so, or what are the roots? Okay, you'll find out why. More about that later. I don't want you to get hung up too much on the definition. I want you to see more of the reasoning. But here's conceptually how you would see that. This is how come you're getting two answers. Before, you've been dealing with linears. Linears just have straight lines. But now quadratics, okay, anything of a power of 2 creates this parabolic shape here. In fact, we call that a parabola. Okay, let's look at this next one here. Okay, solve by factoring. Okay, first things first, we got to get it in standard form. Okay, we always got to think of things like this way. To get in standard form, get back to my red here, we think of this as ax squared plus bx plus c all equal to 0. Okay, this guy right here is not equal to 0 right now, so we can't do anything with him. Okay, so we got to get the 6 on the other side, so which means I'm going to subtract 6x from both sides. Okay, when I do that, I now have 3x squared minus 6x. Notice I do not have a constant over here. Oops. Okay, so I can just make this guy right now all equal to 0. Okay, so now I can start factoring. Well, let's start looking at it very carefully. Notice I do have a way to, I do have a GCF I can factor out. Notice I have a 3, but I also have an x in both of these. So I can factor out a 3x. Okay, we'll come in here, divide everything by 3x, and what do we get? Notice the 3 and an x cancels, leaving me just with x. And then notice here, 6 divided by 3, okay, let's put the minus here. 6 divided by 3 is just going to be 2. Okay, and all of this is going to be equal to 0. Well, that's my factored form. But I can still solve this. I can come in here and go, okay, well, how about 3x equals 0? And then x minus 2 equals 0. Well, notice here, we're just going to divide off the 3, and I get x, okay, equals 0. Okay, and then over here, add 2 to both sides, okay, and I get x equals 2. So for here, the answer to solve this would be x equals 0 and x equals 2. That would be the answer for this. Okay. Now let's come in here. Notice these are quadratics that we've seen before. Okay, and this is going to be a neat one right here. If you look at it very carefully, I can factor this using the AC method, but if we look carefully, we have a perfect square trinomial here, okay? Because I've got a square here, I've got a square here. Okay, let's start looking at it. Okay, remember, perfect square trinomial is something of the form a plus b squared, where that is equal to, okay, a squared plus or minus 2ab plus b squared. Well, let's see if we got it here. Well, notice the square root of x squared is just x. The square root of 16 is going to be a 4. I've got a subtraction in the middle here. Well, does this work? Okay, well, let's look here. 1x times 4 is going to give me 4x. And if I multiply that by 2, okay, I get 8x, which is exactly what I have right here. Okay, well, now I want you to see that this means also that this means x minus 4 and x minus 4, which we can make both of those equal to 0. Okay, like so. And when we do that, we get x equals 4, x equals 4. Now that doesn't mean we have x equals 4 twice. That just means that we have one spot that equals 4. And if you saw this graphically, this would look something like if there was a 4 here, it would come over here and do that. This will become much more apparent to you later on. Don't worry about it right now. Okay, but I just kind of want you to see what that means. That's because there's only one number here. Okay, so let's continue on. Let's look at some other ones here. Let's look at one like this. Okay, first off, one like this, I don't want to have to deal with fractions. So before I do anything with this, I'm going to get rid of the fractions. So notice here that by multiplying everything by 15, okay, that will remove any fraction. So come in here, multiply everything by 15 before I do anything. Here the 15's reduce out. Here the 3 reduces to a 1. This will reduce to a 5. And here the 5 will reduce out, and this will reduce to a 3. Now I can rewrite. I'll do this in black. So I have 2x squared minus, well, here, notice I had the 5, so 5x. Okay, all equal to negative 3. Remember, this is not in standard form yet, so we need to go ahead and move that 3 back over. Okay, so let's go ahead and take this 3 and move it over to the other side because we want this equal to 0. Okay, so we have 2x squared minus 5x plus 3 equal to 0. Huh, straightforward. Now let's factor this guy. Well, I'm going to do the AC method on this one. So 2 times 3 is going to give me 6. Now, are there any factors of 6 that will also add to 5? Well, let's start looking. Notice I've got 1 and 6. Well, 1 minus 6 will equal negative 5. Okay? And negative 6 plus 1 will also equal negative 5. Okay, so that's one that the first one will work out great. So we'll do this as a positive 1 and a negative 6. Okay, so let's come over here. And actually, hold on, let me double check here. Nope, that will not work. I'm very sorry, because look, that does not create us a positive 6, because negative 6 and positive 1 and negative 6 do not create a positive 6. So we're going to have to find something with 2 like signs. But notice if we go to 2 times 3, and if we make them both negative, we can do negative 2 minus 3, and we get the negative 5. And then that also, negative 2 times negative 3, will give us a positive 6. So that works. So let's go and put that back in. We've got 2x squared, okay, minus 2x minus 3x plus 3. Okay, we're going to factor here by grouping. Okay, notice the first part here, I'm going to pull out a 2x. Okay, I'll divide out 2x, and doing that I'm going to come over here and put 2x. And what am I going to get? Well, notice here the 2x is going to cancel out, leaving just an x. Okay, here the 2x is going to cancel out completely, leaving us just with a 1. Okay, always a rule here. You're going to factor out that negative. No matter what, that negative has to come out. So I'm going to factor out a negative 3. And if I divide everything in here by negative 3, notice this negative here is just going to leave an x. Okay? Well, here it's going to leave a negative 1 because I'm dividing a positive and a negative. So that's going to leave me with x minus 1. And so my factored form of this guy is going to be 2x minus 3 and x minus 1. Now it does say to solve this. So let me come over here and I'll do this in blue. Okay, so we've got 2x minus 3 and then x minus 1. Come in here. 2x minus 3 equals 0. X minus 1 is equal to 0. Well, here we'll add 3 and I get 2x equal to 3. Divide off the 2 and I get x is equal to 3 over 2. And over here just add 1 to both sides. Okay, and then I can see that x equals 1. And so my x will equal 3 over 2 and 1. And that's how these are done. Okay, so coming in here, let's look at procedure here. Okay, add or subtract terms as necessary so that 0 is on one side of the equation. And the equation is in the form, standard form. Okay, you're going to hear me say it a lot. We have a quadratic. What do we got to do? Get things equal to 0. Okay, then we're going to factor completely. Okay, continuing on. Set each non-constant factor equal to 0 and solve each linear equation for the unknown, and then check the solution one at a time. Okay, and then common error. Notice here what they're saying, just common error. This is a good thing to kind of look over, maybe pause and just kind of just remember. Okay, what they're saying here is you can't just divide out the x and then just say x equals 2. Okay, what you're trying to do is solve for x. It doesn't work that way. I'm sorry. Do not divide by x because you lose the solution. X does not lose solution of x equals 0. Okay? Caution, factoring is a method used. By factoring, you will find all solutions as shown in the previous examples. Okay? Okay, theorem. If x equals c is a root of a polynomial equation in the form of px equals 0, then x minus c is a factor of the polynomial. Okay, so find the equation with the given roots. Okay, find a polynomial equation with the integer coefficients that has the given roots. Okay, what it's saying here is what we're going to do is just take everything back to its original form. Okay, remember, once upon a time, to get this x minus 3, we had to have it as, or to get this x equals 3, it had to be x minus 3 at one point in time. So let's take a look at the next page here and we'll see what you mean. Notice, we're basically taking it backwards. Okay, even this one here, I'm going to divide off the 3x, and then I'm going to add the 2. I'm getting backwards. Then we get back to this, and then we're just going to distribute. I left this in here. Well, this is going to be on some of your homework. So, nothing too terribly hard, but something you just really need to pay attention to. It's good to know how to go forward and backward with these equations, especially when you get up into later maths.